Hi, today we're going to learn about congruent triangles. Congruence and corresponding parts, Triangles that have the same size, same size and the same shape are called congruent triangles, which makes a lot of sense since we learned congruent means same size and same shape earlier. Two triangles are congruent if and only if all three pairs of corresponding angles are congruent and all three pairs of corresponding sides are congruent. So in this figure over here at the right, triangle ABC is congruent to triangle RST. Now, what's important to notice about this congruence statement is that the matching pieces are shown in the matching order, okay? So like angle A has one arc on it for congruence, and angle R also has one arc on it for congruence. So the first letter here, A, is congruent to the first letter here, R. Also, angle B has a double arc on it for congruence, and angle S in the other triangle has a double arc on it for congruence. So since those two are equal, they both take the middle position of the triangle congruence statement. And last, angle C has a triple arc on it, and angle T has a triple arc on it. So those matching letters are congruent as well. This also works for the segments. For example, the segment that connects A to B has one tick mark on it for congruence, and the segment that connects R to S also has one tick mark on it for congruence. The segment that connects point B to point C has 3 tick marks on it. The segment that connects point S to point T also has 3 tick marks on it, and you'll see that those are the last 2 letters in each triangle congruent statement. The last pair of matching sides is the side connecting the first letter and the last letter, A to C. A to C has a double tick mark on it for congruence, and then R to T also, first to last, has that double tick mark on it. So when you read a triangle congruent statement, it is not just telling you the two triangles are congruent, it's also showing you exactly which pieces of the triangle match up with the pieces of the other triangle. Now we have a theorem here called the third angle theorem. If two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangle are congruent. So if I know the measurements of 2 are the same in both triangles, automatically the third would have to be the same, because there's only going to be one more number you could add with the first 2 to equal 180. So that's called our third angles theorem. Now there's a worked out example here that you can take a look at if you'd like. We're going to go down here to the bottom of the page, and we are going to try these examples. It says, show that the polygons are congruent by identifying all the congruent corresponding parts. So the corresponding parts, that means the matching parts, would be the angles and the line segments. Then you have to write a congruence statement. So this is going to be kind of a lot of writing. In fact, for some of you, if you write big, you may not want to work right on this sheet. You may want to work on notebook paper, but it's not difficult. So lengthy writing, but not difficult to think about. So let's look at problem number 1. We'll start with the congruent corresponding parts. I'm going to start with the angles. So let's go to angle A. It has one tick mark on it. Angle A is congruent to which angle in the other triangle? That would have to be angle J, because it also has only one congruent arc on it. Then we'll go to angle B. Angle B is congruent to angle K, because angle K has the double arc on it. Those are matching. And last, angle C, of course, has to be congruent to angle L, by the third angle theorem. They have to be the same if the first two are the same, but they're also marked congruent with the triple arcs on them. So that takes care of the angles for this problem. Now let's move to the line segments. Line segment AB has to be congruent to whichever one has the one tick on the other triangle, which would be JK. And I'm not kidding. The next one, BC, double tick, is congruent to KL. Double tick here. And finally, AC with the triple tick marks is congruent to JL with the triple tick marks. So there's the three pairs of matching angles, the three pairs of matching sides. Since all the angles and all the segments are congruent, we can tell that the triangles are congruent. So we're going to say triangle. Now, the first one, we could name the letters in any order we want. I'm just going to go A, B, C, since that's how we've got it set up here, is congruent to triangle. On the other one, the order matters very much. Since the first letter is A, this first letter has to be J. Since the second letter is B, the second letter has to be K. And the third letter being C means that the third letter in the other one has to be L. Now, I didn't have to put these in alphabetical order. I could have gone triangle CAB, for example. If I had written triangle CAB, then I would have had to write triangle LJK on the second one. So the letters that match, the angles that match sides have to be in matching places in your triangle congruence statement. So watch for that. Order matters. Now, number 2. Angle A is the one arc angle here, and it is congruent to the one arc angle in the other triangle, which looks like that would be the angle D. Now, I can just name those angles with one letter, the vertex letter, because there's only one angle that has that vertex. But when I move up here to angle B on this left side triangle, I can't just call it angle B because there's a small angle ABC in the picture, there's a medium-sized angle CBD in the picture, and there's a big angle ABD in the picture. So there's 3 different angles, all which have the vertex of letter B. So we can't just call it angle B. We have to name it with 3 letters so that it's very clear which angle we're talking about. So I'm wanting this one with the double ticks on the triangle on the left, so I'm going to call it angle ABC. And that's going to be congruent to the angle with the double ticks in this right side triangle. So that's down here with the vertex of C, but again, I can't just call it angle C because there's 3 angles in the picture which have a vertex of angle C. So I want this one that has the double arcs on it on the triangle on the right. So I'm going to call it angle DCB. The middle letter, oops, I forgot the angle symbol. Angle DCB is, the middle letter is the vertex of the angle I'm talking about. Now I'm going to go to the last angle in the triangle. For the triangle on the left, it's angle C, but again, I'm going to use the 3 letters ACB, angle ACB, to name that angle. Has the 3 ticks. Then over here with the 3 congruent arcs on here, I'm going to call this one angle DBC. Oops, DBC. Okay, so I have written out all 3 angles that are congruent. Now I'm going to write the 3 matching sides. I'm going to start with this bottom one with the 1 tick mark on it. Segment AC is congruent to segment DB because both of those only have 1 tick mark on the picture. The next pair with the double ticks would be segment AB is congruent to segment DC. And then the last pair of matching segments is the one that connects the two triangles. It's actually a shared side. They have it in common. So segment BC on the first triangle is congruent to segment CB on the second triangle. And I could have written segment BC is congruent to segment BC with the same name, but I like to maintain that consistency of going double arc angle to triple arc angle, and then on the triangle on the right, the double is the C and the triple is the B. But it wouldn't be wrong to write it the other way. I just like to maintain that consistent practice. Okay, so now we're ready to write our triangle congruence statement. Triangle ABC on the first one is congruent to triangle. Now the order matters. Which angle is the same as A on the opposite triangle? That's the D. Which one was the same as B from the first triangle on the second triangle? That's C. And then angle C with the triple tick marks on the first triangle was the same as angle B with the triple on the right side triangle. Okay, number 2 is done. Let's scoot over here to number 3. Number 3, they have not marked any of the angles as being congruent. So, in order to figure out which angles are congruent, we have to think about some of the geometry properties that we have learned already this year. Notice the arrows in the picture mark off parallel lines. So the top segment, KL, is parallel to the bottom segment, JM. So those are parallel lines, and then there's a segment from K to M that is a transversal line that cuts through the parallel lines. So when you have parallel lines cut by a transversal, all these angles that are inside the picture here are interior angles, and our alternate interior angles have to be congruent. So this one between the orange and the blue line I drew is going to be congruent to this one between the orange and the blue line down here. So that's going to be my first pair of congruent angles. Angle LKM is congruent to angle JMK. Okay, now there's another pair of parallel lines. I'm going to turn my paper sideways here so that it looks a little bit more similar. Another pair of parallel lines going horizontally now, but it was vertically before. And then that same transversal line crosses through those. So here, these alternate interior angles are also congruent, okay? So that means angle LMK right down here is congruent to angle JKM. Okay, so there's two pairs of angles that are congruent. There's actually not a geometrical relationship between these two angles that we've learned so far having to do with the parallel lines, the last angles, J and L. But we just today learned the third angles theorem. If two angles are congruent in one triangle to two angles in a second triangle, the third angles must be congruent. So those remaining last angles in each triangle have to be the same. Angle J must be congruent to angle L. Okay? Now we're ready to do line segments. So the bottom and the top line segment each have one tick mark on them. So I'm going to say segment KL is congruent to segment MJ. And then the left and the right segments have the double tick marks indicating their congruence. So segment J, or I wrote K, KJ is congruent to segment ML. And then finally, we have this line segment from K to M that is congruent on both triangles, just like it was here, BC. They didn't mark it that way, but they are the exact same segment from K to M. There's no different length between the same 2 points. So KM is congruent to MK. All right, so we've got all the matching parts matched up. So now we can write our triangle congruence statement. Triangle KML is congruent to triangle MKJ. So again, the order that you choose for the first triangle, the letters could go in any order. But when you write the second one, you need to make sure that the matching letters are the same size. So K on the top triangle is congruent to M on the bottom triangle. M on the top triangle is congruent to K on the bottom triangle. And L on the top triangle is congruent to J on the bottom triangle. So those need to be in matching positions, first, middle, or last each on your triangle congruence statement. Okay, this next one, number 4, I'm going to skip and go to number 5. So for number 5, let's look at what is congruent. So angle A is congruent on the bottom triangle to angle D on the top triangle because they each have one congruent arc. Now angle B on the bottom triangle is the same as angle C on the top triangle, but we can't name them with one letter because there are 3 different angles with that same vertex. So I'm going to call it angle ABC. ABC, this one right here, is congruent to angle DCB. And then the last angle, angle ACB, on the bottom triangle, is congruent to angle DBC. Oops, DBC. So that's the 3-arc angle, A to C to B, and D to B to C. Now we'll do the line segments. Segment BA is congruent to segment CD. Those each have 1 tick mark on them. The double tick marks are the tops and the bottoms, so segment AC is congruent to segment DB. And last, the segment from B to C is the same on both triangles, so segment BC is congruent to segment CB. And now we're ready to write our triangle congruence statement. So triangle ABC is congruent to triangle. A is the same as D. B on the first triangle is the same as C on the second. And C on the bottom triangle is the same as B on the top one. So there's our triangle congruence statement. All right, I'm going to skip number 6, and I'm going to go down here to the bottom and look at an algebra type problem. This says triangle ABC is congruent to triangle DEF. This triangle congruence statement is super important because it tells us what the matching pieces of each triangle are. Okay, let's go ahead and mark the triangle so that we know what's the same in each one. Angle A is congruent to angle D. Angle A, 1 tick, is congruent to angle D, 1 tick. Now, angle B is the same as E because they're the middle letters on both. So B is the same as E. And angle C is the same as angle F. So C is the same as, triple F. Got to put the matching numbers of congruent marks on matching pieces of the triangles. Now let's talk about the segments, okay? From A to B is going to be the same as from D to E because those are the first two letters in each triangle congruence statement piece. So AB I'll put 1 tick mark on, DE I'll put 1 tick mark on. Then from B to C, double, those are the last two letters, would be the same as E to F. I'll put double on there. And then the first letter with the last letter, AC, triple tick marks. First letter with the last letter on the other one, DF, triple tick marks. So now my triangles are all marked so that I can easily identify congruent parts, corresponding parts, matching parts, okay? So number 7 says find the value of x. Where do you find the x in the problem? 2x plus y. Well, you can't solve for an x and a y at the same time. So I think we're going to have to solve for the value of y first. Angle D has just the angle y in it. 2y minus 5 is angle D. And angle D has the 1 tick mark angle, so that's going to be the same as angle A on the first triangle. So I can write a statement that says 65 has to equal 2y minus 5. I know that because angle A and angle D, first letter, are equal to each other, okay? So that's my first equation, and I can use that to solve for y. So I'm going to get the y by itself. First, I will add 5 to both sides of the equation. So 65 plus 5 more makes 70. 70 is 2y. And then to get the y by itself, I divide both sides by 2. So half of 70 is 35. So the measurement for y, the variable y, is 35. So now I can solve for x because I know that this side from E to F, the last two letters, has to be the same as the segment from B to C, the last two letters here. So EF is 2x plus y, and that's going to equal from B to C, which is 90.6, okay? But we do know what y is at this point, so we're going to drop the y value of 35 in place of the y. We're going to do a substitution. So 2x plus 35 will equal 90.6. So I'm going to solve this equation for x right now, and I will do that by first subtracting 35 from both sides of the equation. So 2x is all that will be left on the left, and for the right I'm going to subtract. So borrow from the 9, make it an 8, bring the 1 over. 10 minus 5 is 5, 8 minus 3 is 5. And now I'm going to divide by 2 on both sides. So x is going to equal 55.6 divided by 2. So 2 times 2 is 4. Let's see, 2 times 7 is 14. And 2 times 8 equals 16. So the answer for x is 27.8. All right, let's move on to the next problem. So this part says prove triangles congruent. Two triangles are congruent if and only if their corresponding parts are congruent. Corresponding parts include corresponding angles and corresponding sides. The phrase if and only if means that both the conditional and its converse are true. For triangles, we say corresponding parts of congruent triangles are congruent, or CPCTC for short. Okay, if you are here with me in class today, I would have you repeat after me. So wherever you are, I would say that saying this out loud will help you to remember it. This is an important statement that you're going to be required to know for upcoming problems, quizzes, reviews, tests, and semester exams. So, corresponding parts of congruent triangles are congruent. Say it after me. Corresponding parts of congruent triangles are congruent. Keep in mind the word corresponding means the matching parts. Corresponding parts of congruent triangles are congruent, and the abbreviation that we use for that so we don't have to write that sentence out every time in a proof is CPCTC. Repeat after me. CPCTC. Okay, so the first, the middle, and the last letter are all C's. Corresponding parts of congruent triangles are congruent. Okay? So there is one proof worked out fully here for you, and we've got two to do on our own. And on these proofs, we have to show, in both cases, that the triangles are congruent. And the way that we show the triangles are congruent is by showing that all of their corresponding parts are congruent. So, let's see, it's going to be I'm going to have to write kind of small. I'm going to try to squeeze it right here. We'll see. So we've got statements on the left and reasons on the right. So my first statement that I start with is the given information, and as I write it down, I'm going to mark it on the picture. Angle A is congruent to angle C. So angle A is congruent to angle C. That's given. Angle D is congruent, to angle B. So D double is congruent to B double. Segment AD is congruent to segment CB. AD 1 tick, CB 1 tick. And segment AE is congruent to segment CE. So from A to E is congruent to C to E. Then we're also given one more thing. There's a lot of given information in this proof. Segment AC bisects segment BD. So what does that mean? This line from A to C splits the line from B to D down the middle. Bisect means to cut in half, like dissect. When you dissect a frog, you cut it up. And bi is a prefix that means two, like a bicycle has two tires. So dissect into two equal parts is basically how this word breaks down. We're cutting the segment from B to D into two equal pieces by splitting it with the segment AC. So the reason we know all of this is true is because it's given. Now we need to figure out how to make the last matching pieces of these triangles to be congruent. Well, we didn't mark anything on our picture with this statement AC bisects BD. If this segment AC split BD down the middle, then that means it separated it into two equal parts. So I can say BE is congruent to DE, segment BE is congruent to DE, and the reason is because of the definition of bisect. The word bisect means cut into two equal pieces, so those are the pieces that are equal based upon that statement. AC bisects segment BD. Now, we have all three sides in the triangle are congruent to all three sides in the other triangle, but we only have two angles that are congruent in one triangle to two angles in the other. This last pair of angles is congruent, so I'm going to write that. Angle AED is congruent to angle CEB. And there's more than one reason why I could say they are congruent. I could say they are congruent because they are vertical angles. Remember, when you have an X, the angles opposite from each other are called vertical angles, and they are congruent. Or you could also use the theorem that we learned earlier today called the third angles theorem. If two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles are congruent. So I'm going to say vertical angles are congruent, but if you wrote third angle theorem, that would also be a good reason to support that statement. Now, what are we trying to prove? We're trying to prove that these two triangles are congruent, and we now have all three parts, the angles, and all three segments are the same in both. So we can go to our final statement, and I've totally run out of room. I should have come over here to the right side. That would have been smarter. But we'll go statement 4 is triangle AED is congruent to triangle CEB. And the reason that we know that's true is because of CPCTC. Corresponding parts of congruent triangles are congruent. Remember, this is actually an if and only if, a biconditional statement. Both the conditional and its converse are true. So if the corresponding parts of the triangle are congruent, the triangles are congruent. So we're going to write CPCTC for our reason for that final statement. Okay. The next problem says to write a paragraph proof, but I'm not going to write a paragraph proof. It has been my experience that most geometry students prefer to avoid paragraph form. So we are going to stick with the two-column proof. We're not going to work with paragraph proofs. Statements and reasons. Okay, so my first statement is going to be the given information. Segment BD bisects angle ABC and angle ACD. Oops, I forgot the S. Bisects. And we have segment AB is congruent to segment CB. Segment AB is congruent to segment AD. That doesn't look like it in the picture, but it says AB and AD are the same. And segment CB is congruent to segment DC. CB, DC. So those are supposed to be isosceles triangles, although the picture is not drawn to scale. So the reason that we can say all of that is true is because of it all being given information. So now we need to prove all three angles and this remaining side are the same. Let's start with that remaining side. That remaining side is a shared side in both triangles. From B to D on the left triangle is the same as from B to D on the right triangle. So for my second statement, I'm going to say segment BD is congruent to segment BD. And what reason can I say something is congruent to itself? Do you remember earlier this year we learned a property that something is congruent to itself was called the reflexive property? I told you it's kind of like a reflection in a mirror. Okay, So you probably thought, why would we ever need to say something is congruent to itself? Well, if it's the exact same segment on both triangles, we can say that segment is the same on both by the reflexive property. So here it finally became useful. Now we need to look at the angles. We have this statement, segment BD, this one going right down the middle, bisects, remember, cuts into two equal parts, angle ABC, the top big angle, and also the bottom big angle, oh, I wrote it down wrong, ADC, ADC. So what does that mean? Those big angles got split right down the middle. They make two smaller equal angles. So I'm going to say angle ABD is congruent to angle CBD, and at the other end, angle ADB is congruent to angle, ADB is congruent to angle CDB, and that is by the definition of bisect. When you bisect an angle, you split it into two equal smaller angles. Now we have one remaining angle in each triangle, and those have to be congruent. So angle A is congruent to angle C. I can name them by one letter because there's only one angle at both of those vertices. And the reason is what we just talked about today, the third angle theorem. If two angles of a triangle are congruent to two angles of another triangle, automatically their third angles must be congruent. So matching triple tick marks on those angles. Okay, so now I have all three sides of one triangle are congruent to all three sides of the other triangle. All three angles of one triangle are congruent to all three angles in the other triangle. So now I can use my prove statement and prove that the two triangles are congruent. Triangle A, B, oops, I forgot the triangle symbol. Triangle ABD is congruent to triangle CBD, and the reason is CPCTC. Okay, that concludes our lesson on congruent triangles for today. I hope that you have an awesome time doing your homework and feel really good about it. If you have any questions at all, please reach out to me and ask for help. I would be more than happy to help you in any way that I can. Have a fabulous day. Bye for now.